Hey guys, welcome back to another IM2 video, and today we're going to be going over proofs. So this video is, I'm literally going over like the basic, most simplest parts of proofs because it is so crucial that you understand like the fundamental part of proofs because it is going to be like a big part of this unit of geometry. So firstly, what exactly are proofs? So proofs are step-by-step arguments that use definitions, postulates, and theorems to demonstrate that a geometric statement is true. Okay, so definitions of like what we're referring to by definitions, we just mean like of geometric rules. For example, if you guys know like CP, the definition of that. We also have postulates, and if you guys don't know what postulates are, they're just like statements that are accepted to be true / fundamental math concepts, if that makes sense. So for example, if we bisect a line through its midpoint, each side of the bisectors are going to be even, if that makes sense. With proofs, you're literally trying to prove something. So for example, if the way I like to think about it is you're trying to explain something to like a 3-year-old kid. You know, like those toddlers when they get into their whole little like why this, why that phase. That is what I'm thinking about when I'm thinking of proofs. Like for example, if we had a triangle and the question was prove, or like let's say that we had 2 triangles and the question was like prove 2 triangles are congruent. So, for example, you could literally just say and be like, well, they look the same. Like, okay, right now they don't look the same. That's on me. But that could be like one of your defenses. But a little kid would be like, okay, but why? And then you would start stating this. You'd say, oh, well, because they have 2 congruent angles. You'd be like, okay, but why? And then just so on and so on, if that makes sense. Like, you're literally proving every single step and every single point of your argument. Okay, now let's look at the types of proofs. So we have different kinds of proofs. So firstly, we have a 2-column proof, and this one honestly I prefer simply because it's a lot easier to not mess up. It's really hard to mess this one up. Like for example, the way this would work is, let's say you have a statement. So let's say we have 2 triangles, A, B, C, D, E, F. Okay, so the problem is going to say like prove these 2 triangles are congruent, and it says given that segment AB is congruent. Also, this is the congruency symbol. Just so you guys know. Segment AB is congruent to segment DE. Right? Okay, that's all we have. That's all we got right now. Okay, this obviously isn't a right angle, but let's pretend that's a right angle for now, just so it can make a little bit more sense. Okay, you know what? Let's just ignore that part, guys. Okay, so what I would first start with is everything that I'm given, right? You would say segment AB is congruent to segment DE, and your justification would be given, and then you'd continue. And then you'd say angle B is congruent to angle E because right angles are congruent. Did you guys see how I just said all right angles are congruent? This is actually like one of the postulates. It's like a postulate because it's a statement that everybody agrees is true. Because obviously if this 90-degree angle is 90 degrees and another 90-degree angle is 90 degrees, they're congruent, obviously, because they're the exact same. I like this one a lot just because you can like, continue, you can keep writing your statements, and it keeps everything really clear and concise. Okay. Okay, so paragraph proofs are literally if you were to write an argument essay about geometry. Like, if the question asked you, prove that these 2 triangles are congruent, you're literally just going to write out every statement, like a sentence and a paragraph, just to make sense. Be like, okay, segment AB is congruent to segment DE because of this and this and this, and so on. It's literally just one fat paragraph. Okay, then we have flowcharts, and flowcharts are kind of like similar things. It's just like you write one statement, you write a statement that connects with it, and so on. Like for example, if I said angle AB is congruent to angle DE, this is true because it was given. Then we have, what was the other one? Oh yeah, Angle B is congruent to angle D. Our reasoning, all right angles are congruent. And then eventually they would all, sneak peek. Eventually they would all like get to the part of like triangle ABC is congruent to angle DEF, if that makes sense. Like they all end up resulting in one big statement. So it would kind of look like these little squares, and they all feed into this big statement that we're trying to prove. Okay, now that we kind of like talked about proofs in general and like what they are, we're going to talk about different concepts that are really helpful for proofs. So firstly, here we have the triangle congruency triangle congruence criteria. And all it is these are like pretty useful just to know, because it's really common to get problems that are like, oh, prove these triangles are congruent. And you are most likely going to need to know these examples, or like these concepts, if that makes sense. You can prove that a triangle is congruent if they have the same 3 sides, right? If like all 3 of their sides are equal to each other, it's congruent triangle. That's just how it is. Now, if 2 triangles have the same side, angle, side, if you guys need like a visual. So let's say we have 2 triangles and we say these 2 are congruent, these 2 are congruent, and this angle is congruent. That's all you need to know. That's all you need to have to prove that these 2 triangles are congruent. Now, if we have angle, side, angle, all we need is to say this angle is congruent to this angle is congruent to this one, and these 2 sides are congruent. And bam, you just proved the congruency of those 2 triangles. Now, angle, angle, side. I hope you guys are like picking up the pattern, if that makes sense, but this is just angle, angle, and then side, right? This is all you need to prove that these 2 triangles are congruent. Now, we also have similarity theorems. Now, this is to prove that triangles are similar. Now, if you're not exactly sure what similar means, it just means, okay, for example, if I had these 2 circles, they are similar because they're literally the exact same circles, they're just different sizes, okay? When you think similarity, you can sort of think sizes. So these 2 triangles might have, it's actually a really bad example. Okay, these 2 triangles might have the same side, might have the same angles. In retrospect, they sort of are the same angle, but they are not exactly the same because they are different sizes. That's the way I like to remember it. So the way you can prove that they are similar is if they have 2 consecutive angles that are congruent. 3 sides, 1, 2, 3, 1, 2, 3. Yep, those are similar. So like my way of thinking about it is like if you enlarge this triangle right here, you would get this one. Yeah. And then side, angle, side. So if it's side, angle, side, those are similar. And also congruent. But yeah. Okay, now let's look at some, not examples just yet. We're going to look at some more rules that I would say are pretty helpful to this. Now, we have, this is literally kind of just like a summary of what I just said. We have how to prove they are congruent. This is a better visual if you guys want to see. You guys can screenshot. Feel free to do whatever. So we can see if we have side, side, side. They're congruent. Side, angle, side is congruent. Angle, side, angle, 2 angles, and an included side. So as you can see, it goes angle, side, angle. They have to be in that order. You also have angle, angle, side, angle, angle, side. And then we also have the hypotenuse leg, which just means that the hypotenuse of any one leg of the right triangles are congruent. Okay, if you have 2 right triangles and any one of their legs are congruent to each other and their hypotenuse are congruent to each other, then you know that they are congruent. Okay. Then it's just like explaining why we can have congruent angles or congruent sides. For example, it can either be given to you. It is the definition of a midpoint, aka midpoint creates 2 congruent sides. These are sort of just like rules that will help you create these proofs. And then reflexive property, a side is congruent to itself. If you guys want like a visual of that, for example, if we have this, this segment is congruent to itself because a side is congruent to itself, right? Like if this was AB, segment AB is congruent to segment AB because of the reflexive property. Now, we can also have congruent angles if there is a vertical angles, if they are alternate interior, if they are corresponding angles, must have parallel. Okay, this is what they mean. Right? This is what we're looking at. And then corresponding angles, and then the definition of a bisector. A bisector will create two congruent angles. So for example, if we have this line and this bisector goes right through it, it just bisected that line, which means to split it in two. So that means these angles are not congruent. They're also right angles, but yeah. Okay, then we also have CP-CTC, which is just the corresponding parts of congruent triangles are congruent, which is like, sounds really silly, but it just means if we have two congruent triangles, like we already proved that they're congruent, then the parts that correspond with one another, for example, A corresponds with B, C corresponds with D. We can say that segment AC is congruent to segment BD because since we know that these triangles are congruent, their corresponding parts, this part corresponds with this part, are also congruent. Yeah. Now, here is like an example of a proof. We're going to like walk right through it. I'm just going to explain to you the thought process behind it. So, for 6, it is given. Segment PR bisects angle QRS, angle PSR. Wait, this is separate. Sorry. And then angle PSR is congruent to PQR. So as you can see, they went ahead and they labeled everything that is congruent and what is not to each other. So they started off by saying PR bisects this because obviously it was given. We can literally just write that down. We can say it was given to us in the problem. Then we have angle 1 is congruent to angle 2. And the reason, their explanation for this is that it's the definition of a bisector, right? And we just reviewed that if we bisect something, right, the two angles it creates are congruent to one another. So that's where we get this part here. Then we have angle PSR is congruent to angle DQR, or angle 3 and angle 4. Which, that sounds a little complicated, but it's just saying like these two angles are congruent. Now, we have to justify why they're congruent. And the reason is because it was given to us, which you guys can see right there. And then we also have segment PR is congruent to PR, which once again is just a reflexive property, which means this angle is congruent to, this segment is congruent to itself because it is reflexive. And then we have triangle PSR is congruent to triangle PQR, and the reason for that is angle, side. The way we can prove this is that we have a corresponding angle, corresponding side, and we have another angle. So angle, side, bam. That's all we need to prove that these two triangles are congruent. So as you guys can see, we're really just proving the whys. We're trying to find the rules that will prove to us that these things are congruent and that these things are true. And the way we do that is we use this by using theorems, postulates, and definitions. Okay guys, that is it for today's video. I hope you guys enjoy, and I really hope that was helpful. If you guys have any other questions, feel free to leave a comment or request tutoring with Mu Alpha Theta. Have a great day guys. We'll see you guys in the next video.